Hi everyone, I'm Malavika. I'll be presenting our study assessing environmental condition during bird strike incident, a study across select Indian civil airports. I may introduce my team, myself Malavika, and my co-researcher in this study is Mubin and Pratik. Along with us, there is a bunch of researchers who helped us in GIS, data entry, etc. Who are Riaz, Shikha, Ashia, Subhash, Sanitha, Smriti, and Santo. This study was carried out under the guidance of Dr. Pramod P. At Salim Ali Center for Ornithology and Natural History, Wildlife Institute of India. So what we know is bird strikes are significant global challenge. It can place human lives at risk and create potential casualties. It can also create financial losses by creating aircraft repairs, operational delays, flight cancellation. This also disrupts flight schedules, inconvenience to passengers, affect airline reputation. So India being one of the biodiversity hotspot with more than 1,300 species of birds, it is also a part of Central Asian Flyway, which is a significant migratory route for over 600 species of water birds, which spans a vast area of Eurasia covering 30 countries. So it is very evident that India is one of the significant places to study about birds and its hazard to aircraft. So let's see the timeline. 1903, first human flight by Wright brothers. 1905, first record of bird strike by Oral Wright. 1909, first record of mammal strike, which was a farm dog, ran into the spinning propeller. 1912, Calbreth Roger flew into a flock of birds, causing the plane to crash into the sea. 1960, very tragic thing, a flock of starlings struck into the plane and the plane crashed into the sea and 62 people tragically lost their lives. And on 2009, a very interesting thing happened. US Airlines hit a flock of Canada geese, causing both engines to fail. And surprisingly, Captain Sully landed the Airbus on Hudson River, saving all 155 people. And it was later known as Miracle of Hudson. And later, this incident was shown in the movie Sully 2016. So the knowledge gap we found out was environmental condition prevalent during bird strikes are very rarely studied. So this led us to a question. Are bird strikes purely random or are they more likely under specific weather or environmental condition? So this led to the hypothesis bird strikes are likely to occur more often under specific environmental condition rather than being random events. So the data size we have is 629 bird strikes from 7 Indian civil airports. This data is solely collected by airport authority individuals. So the environmental variables we considered were humidity, pressure, visibility, wind speed, temperature, and precipitation, which was collected from platforms like Copernicus Climate Change Services. The tools we used is principal compound analysis, k-means clustering, classification, and regression tree. These were used to categorize and group environmental variables prevalent during bird strike incidents. So let's have a macro view on how our data is distributed. I would like to call it as bird view. So seasonal trends in bird strike shows that monsoon has most of the hits compared to pre-monsoon and post-monsoon time. And in a year, June, July, August, September, and October has most of the hits compared to other months. So this is the time when most of the hits are happening. So from this graph, we can get an idea on the time interval where most of the bird strike happen in a day. So here it is evident that evening 7 to 10 is the most crucial time where most of the hit happened, followed by morning 7 to 10. So these two time periods are very crucial when it comes to bird strike in a day. And Most bird strike happen during takeoff and landing, since aircraft fly very low at this point of time. And also these phases are very rigorous and critical part of flight movement. So let's say the birds involved in bird strike events. Charidiforms is the bird order that is involved in bird strikes the most, which involves waders and shorebirds, followed by pessariforms. They are perching birds, and it is the largest bird order, followed by pelicaniforms. They are medium and large-bodied water birds. Chiroptera includes flying mammals, bats. Accipitriforms are birds that are diurnal birds of prey, like kites, hawks. And we found that lapwing is the most involved birds in bird strike. So let's have a micro view, which I would like to call it as frog view. So the PCA test showed that bird strikes occur within space defined by temperature, precipitation, and visibility humidity with distinct seasonal patterns. So this 51.2 variance means these two weather types together comprise about half of all the bird strike incidents. So in one line, we can say that PCA showed that bird strikes don't happen randomly in any condition, but most bird strikes happen in two main weather situations: hot and dry, or humid with low visibility. So our cluster analysis have identified two environmental regimes: moderate, warm, low precipitation environmental, where 96% of bird strikes is happening, and cold, high precipitation environment, where only 3.7% of bird strikes are happening. So our clustering showed two clear patterns. Almost all bird strikes happen in warm, dry condition, while only a small fraction is occurring in cold and rainy condition. Classification and regression tree analysis gave us a very clear operational threshold. For example, when humidity goes above 89%, 89.5 percentage, which usually means monsoon, we know bird strikes are more likely. Likewise, temperature greater than or equal to 31.6 degree for pre-monsoon classification, humidity less than 89.5 for post-monsoon classification. So this has achieved 82.3% seasonal prediction overall. So we have reached at a conclusion that most bird strikes, therefore, are linked to warm, low precipitation environment, which actually makes our hypothesis true. Environmental variables like temperature and humidity predict seasonal strike patterns, and months from June through October witness most of the bird strikes. Most hits involve lapwings and other waders, followed by raptors. So in summary, understanding these patterns provides airports with practical and evidence-based tools to mitigate bird strike hazards before they happen, improving both safety and operational efficiency. Thank you.